Welcome back to another EV Hangout video podcast where the rising tide lifts all boats. Tonight we got a star-studded crew, and we're going to talk about battery options and potential upcoming classes. Tonight we got Jehu Garcia. How you doing?
In the house. Good. Glad to be here.
And I thought Team Arc Blast would join us. They just finished the 24-hour Lemons, and they finished. And I think they got an award for that. They didn't win, but they did finish. So, and that's battery swapping and all that. So it's kind of a big deal. Yeah.
Wow, that's going to be cool. Yeah.
24 hours.
24 hours. That's impressive.
You know, finishing a race like that is important. And in case you need to not finish your charging session because someone is coming at you all aggressive, you need to get yourself an EV Ject. And don't forget to use our code EV Hangout 10 to get yourself a breakaway EV charging adapter. So check them out. Also, Mr. G, what else supports this episode?
Mr. G's workshop. This is here in New Jersey. We teach intro to welding, intro to mechanics. Talking about 3D printing the ring compressor. I do a small engine class, and we're also going to have electric car class. I'm aiming for a 1-week class in August 5th through 9th here in Jersey before I head out west to the EVLC, who also has a class, I think on the 16th. Yeah. So check it out. Yeah, we'll put all the links in the description. And that's actually part of the reason we got Jehu on the call tonight. We want to know, what battery options do we have if you're doing, let's say, educational conversion, or you're going to do a typical conversion like the Volkswagen? I guess not typical, but probably the best candidate.
Yeah.
And then
roadworthy one. Yeah.
Yeah. There you go. Yeah. And then yeah. So let's get into options, and then also
first. Introduce him and his company, and what does he do? So
yeah, if you don't know who the great Jehu is, what's he know about batteries? You know,
what do I?
He makes like great camera stands and stuff. They're really good for photographs and like light holders.
Yeah,
what's cool? That story probably hasn't been told in a while. I'll just briefly tell my version of it, and it's really good. So basically, if you were into like making movies, like 15 years ago, about you only had the camcorder option, and so this didn't have a good lens on it. It didn't have a film quality lens.
No depth of field.
No depth of field. All right.
No depth of field. Yeah.
And so what Jehu figured out was, well, some people have come up with this adapter. You screw on the adapter, and now you can put your DSLR adapter on there. But a lot of people wanted to say, hey, can I have one of those? So he says, okay, sure. And then he starts making them for more and more friends and family and other people. And then he got into production, and he solved a major issue, changing the DIY film people. And if you're a Kevin Smith fan, or any sort of, if you're like a, what do they call it, like
firing
independent film.
Yeah. Mm-hmm.
Yeah, independent film. My friend John Lip does the Big Apple Film Festival. Was all about a festival that was outside of the Hollywood festivals. So it's not easy to make a film. And this is before Casey Neistat. This is before DSLR had video. And then what happened when the DSLR, that was the collapse, because now they offered it, right?
They did, but I just jumped right into it. I went and bought myself a 5D Mark II, and then I started making stuff for that one now, because that was the next frontier right there.
Yeah.
That was the next.
So Jehu's been solving Jehu's been solving the DIY problem for a very long time. And then we're lucky he jumped into the EV space, and he actually started making his own batteries and coming up with solutions for that and filming all this. There's also YouTube really good at the YouTube, gets the word out there, explains it really well, and makes it cinematic. And so, years ago, I met Jehu when he came to New York. I was like, oh, you got to see the car we built. And I took him for a ride in the car we built around Manhattan before we ran out of juice.
That's right. We almost
Yeah.
ran out of juice. Well, when I was in the car, and then later you went and ran out of juice without me.
I remember you said, "Well, are you calculating the amps? Like where do you do this?" I was like, "Well, I just feel the pedal."
He's like, I just feel it. It's by feeling. That's how I know where I'm at.
It's BMS.
Yeah.
Oh my God.
But that one
So-
early on had lead acid batteries, right?
Yeah.
Yeah.
Yeah. It was like these 8 AGMs, so you could put them any which way.
Yeah.
And
Days.
it was pretty cool. So so anyway, that's a pretty good intro. But now you've jumped into batteries.
Yeah. Batteries. Batteries. That's all we do around here now. And just recently started going really hard on the electric vehicle batteries. Because for the longest time, I was just like, I don't want to get into that because they're hard to move. They're hard to get, And so I was like, I'm just going to kind of concentrate on the little batteries, like the little ones, the scooter ones. And we're doing crazy things with those, with the scooter ones. In fact, we are doing a build right now. This car that's back here, the bus, we're going to put 130 of these scooter batteries in there because they have the same energy density as Tesla Model S, and they're smaller, so that means you can build boxes like different shapes and sizes. And these cars have like a really thin space in the floor area that nobody ever uses to put batteries. I think right now somebody's putting Model 3 batteries for the first time on a bus, but that's really hard compared to what we're doing. We're putting these little batteries and we're making our own custom boxes, and they're going to be like, they're going to fit nice. So we're fitting our batteries to the car. They're changing the bus to fit those Model 3 batteries and stuff, right?
And
Nice.
so you're putting in the floor?
In the floor, yeah. It's going to be in the floor. We're going to make custom boxes in there. And there's not going to be any batteries inside. We're not going to lose any space inside.
Oh, in the cabin. No cabin space lost.
Cabin space, yeah. So no
Awesome.
under the seat. There's none of that. It's going to be in the gas tank area and underneath the floor.
So you brought up a point, like you're now doing more automotive batteries. Can you tell us what distinguishes a 18650 that's for automotive or for scooters or for laptops? Like what's the big difference there?
Well, to tell you the truth, there's not much difference. So it is believed that Tesla, for example, is the only one that uses 18650s. Tesla and now the 2170s are like, I guess, the next generation of 18650s, right? Cylindrical cells, right? But a lot of cars are not using that. Most people are now using LG Cam or Panasonic, prismatic, sort of like these ones right here. But so Tesla, they've been claiming that they've changed the chemistry on their like super packs and then the ones on the Model S. But I think there's evidence coming out now that they basically just take Model S modules and they throw them in the super packs and they throw them in the and the power walls. They're not really making several types of cells. So I think the chemistry is identical, right? Now he's always said that they're optimized for a different thing, but I think that's all just PR nonsense. I think they're the same cells, and it's like they can't. I think if you were to compare a laptop cell from 20 years ago, because a laptop stopped using 18650s like a long time ago, they will see some major differences there because those are made to run a small device for a long time. So the max continuous output is a couple of amps or whatever. Where the ones that they're using on the Tesla modules, those are a little bit more. They're like 3C cells or whatever. And by the way, 3C is not that big. It's kind of a normal output when it comes to lithium cobalt oxide batteries, right? So there are bitter batteries that can put out way more power, like 20 Cs, 30 Cs. So when it comes to that, like 18650s are kind of mild batteries. They're not they're not super batteries when it comes to power output. But the energy density it's a bit it's on the good side, at around 130 watt hours per kilogram or something like that, right? And so yeah, there's not much difference. I mean, when it comes to modern 18650s and then what's on the Tesla modules, there's not much of a difference.
So the difference
So
would be
what-
basically ampacity, right? How much you can put in it.
How much you can draw out, but like I said, like those ones and the Tesla's ones, they're not that crazy. Like they're not high power cells. They're kind of in the middle road. So what I'm putting, watch, do I have one here? So I'll give you an
Yeah,
example.
are you gonna do scooter batteries? Is that what you're doing?
Yeah. Let me get one.
Okay, yeah, that's what I want to see. Let's see what he's gonna put in the Volkswagen bus.
So these batteries here,
Was that on your website too?
that is, I think if this one's called an R14. If you search on the website, it'll come up.
All right,
So
I'm just
this
gonna
is
zoom
from-
in on you for now on, just for now for this part. Yeah, go ahead.
So this battery pack here, it's 40 cells. So it's about half a kilowatt hours, like 470 watt hours. And they have the MH1 cells from LG. These are 3,400 milliamp hours.
Oh, okay.
They put
Bigger.
about these. So this is almost exactly the same version of the Panasonic cell that is on a Model S, right? But this one is in this little pack, 40 cells, 36 volts, right?
Oh, wow.
And these come out of fleets of scooters for, who was it? It was like I forget the company that has them, but I mean there was like it's like hundreds of thousands of these out in every city or in cities
Wow.
around the world, right? And so
So
at
is it
this
like
point-
the city bike? I guess in every city, there's one company that sort of dominates that city sort of bike share program, but there is an E option, and it's more than ever now. Like half
Yeah.
the bikes are E option now.
So these were second gen. The first gen were 9-bot scooters, and Uber used them, and all the other companies use them. I forget the names of the other ride-sharing companies that are doing on the like scooters, right? These are like second gen. So these were better. They use better batteries. They use more capacity. And so this is what we're using because we can basically it's the same as a Model S module, right? And except it's smaller, so we can fit it in better shape and forms that are, And all we're gonna
Nice.
do is just use we're gonna put them, they have a BMS, and we're just gonna put them in 3 in series, and that'll get us to 30S, which is where like our little system is in there. On the other ones, I'm gonna do 4, so that'll get us to that high voltage one, somewhere 160 volts or something like that, right? So I've done
Okay.
tests already running that much current or voltage through the BMS. It's gonna work. So now we're gonna do it for reals. We're gonna put them in that car, and then we'll see how that goes. And the other thing about these is they're really cheap because they were out of the decommissioned fleets, right? Like there was like literally like hundreds of thousands of these scooters that needed to be crushed because
Wow.
God forbid, like they have the wrong logo on there. And so
Oh yeah.
when Uber, it says they say Uber and now the new company is something else. Oh no, send those
Yeah.
to the recycler, and then the recyclers don't know what to do with them because they're hazardous material. So then, that's my chance to buy truckloads of those.
There you go. Nice. Dude, so that's great. So now do you have a video of you doing a heat? Because I know you do the heat camera test, which is pretty cool.
I've done some of those on the high, like on the high power ones, right? Because I wanted to prove is like so those have like some crazy claims. Oh, you can do 10 C's or whatever. You can do 600 amps on this little tiny little battery or whatever. So then I'm doing bus bars for them, and everybody's telling me that my bus bars don't work because they're made out of PCBs or thin aluminum, like bus bars. And I'm like, let's throw a load on one of these packs, and then it's like I can make claims all day, but I could just actually test it and record it, and then it's like if you don't believe me, believe the data or don't, it's like, but
Right.
at least I put the videos on these ones since we're not going to be pushing them that hard. I haven't made specific videos for that. I've done tests like that, for example, where I do test the capacity to see how much is in there. Because
that's
these
pretty cool.
have been in pallets for a few years now, a couple of years at the very least.
Were they all sitting pretty low, or where were they kind of at, or were they all over the place when you got
They're
them?
all over the place. Yeah, that's the thing about these, that they're all over the place. But these, the interesting thing about them, these were in fleets in Mexico. So Guadalajara had Monterrey. I mean, there's all the major cities in Mexico had fleets of these. And then when they got decommissioned, they all went to a central place. And then one of my suppliers went through the trouble of actually importing all these batteries to the United States, which was not easy, right? He told me that he had to use an importer that imports nuclear waste.
Oh my
Because
God.
that's the only guy that had all the clearance for hazardous materials across the international border. So they had to do all kinds of things. Like they had to wrap them, they have to put them in this thing, they have to put like with flame retardant materials around them, and they have to separate them. But he was able to get them in States, and then I bought a truckloads of those, and I have them here. So these are all Mexican, from the Mexican fleets.
Got it. Interesting. The thing that people might not realize that you do, which is that not only do you vet these out and check them, but then also you come up with this PCB board like solution, and it basically makes it so much easier to wire these up. But let's get to that in a second. Let's take Kevin's question. Go ahead.
Yeah. So I had a couple of questions on these. So then they're all different, right? They're at different voltages and different states. So before you're putting them in your bus, are you balancing them out, or are you just finding a bunch because you have so many that are close enough, or what are you doing?
Yeah. Yeah. So at the very least, we're checking to see voltage. We're checking to see that there's no bad. They're not out of balance, right? And they're not dead. And then we're just charging them all the way up and then bouncing 3 sets, because we're putting 3 sets in series. And so that's what we're going to do. And then we're going to put them together, then connect them parallel, and then we'll let them figure themselves out.
That's a good point. That and I'll lead on to my next question so you're installing them at the top because that's where you can balance them and they'll be relatively predictably balanced, right?
Yeah. And we are finding out that this BMS wasn't the greatest at keeping these perfectly balanced. This particular version, I have other versions of 40 cell packs and stuff, and there's some that are perfectly balanced when we get them. We have pallets and we go through them and we test. This one's in particular, there's like half of the pack that was like slightly lower than the front half. And we're like going like, what in the world? And everyone, it's pretty consistent. So we're like, oh, this is a BMS thing. Like this BMS is not the greatest in the world, It's like, so what we're doing is we're balancing that half manually, and then we're going to put it in the car, and then we'll see, how long it takes. It might take a year, it might take 2 years for that same condition to reappear, I think, right?
Okay,
so
get out of balance again.
But
do these BMSs give you actual reports of voltage per cell, or is it just like?
Oh, I'm sure there is. I just don't have the tools to do it, right? So we're just doing like manual tests where we put 3 in series, and then we'll put a load, and then we make one lower voltage than the other one, and then we'll see what happens at the bottom. That the one BMS cut off and then like disconnect the entire string, and it does, and then we try it at the top. We're gonna overcharge one, see what happens, and it'll disconnect. And so I'm like, okay, maybe the next one is like we're gonna try it and heat it up or something. And so we're doing a bit like preliminary tests like that to make sure what the things that is gonna happen when we have 3 in series and what would happen. So
how many of these come in on a pallet, and how long do you think it takes you to check a whole pallet's worth, like that whole process you just said? How long does that take you and your team?
Well, we're just starting that process right now, because right now we've been selling them just for people to use them in their own DIY e-bike for their own, right? But we're actually going through that right now. So I think I don't have particular numbers right now, but we seem to have been spending a lot of time to do these first little boxes. We're doing 4 boxes, about 18 kilowatt hours or some 20 kilowatt hours that we're going to put in the gas tank area. And so we're preparing those right now. And I think we haven't developed like a technique right now to just like process a bunch of them. But I think as we move along, like we'll get quick at it. So yeah, it's not going to be too much.
The initial batch you sold was then just, buyer beware. You're getting random cells, they're untested.
So we're selling both. We're selling untested packs for one low price, and then we're testing some here in house, and now we're selling those as tested also. We're leaving the customer, decide like, do you want to roll the dice on these, or do you want something that we went and tested out, and then we have different tiers for those.
So you're giving people that option. So
yeah,
you're buying enough of them, you'll buy extra and then use the best ones, you'll get a better deal. So
yeah, and then we're definitely taking the ones that are like, for sure they're bad, like 0 voltage, or they're corroded, or they're, or there's signs that, or they're mashed, or there's everything in those pallets. Then we're putting those aside. We're like, we don't want to sell these to someone that is later going to have trouble and, catch up fire on them and stuff like that. And so then we're putting those in a pallet on a Gaylord. And I just sold 3 of those Gaylords, by the way, to a company that is going to make black mass. They're going to shred them down to get the components and stuff. So even those we sell them for some money,
That's a pretty cool module you found there, and it seems like you have a good application potentially for vehicles. Lately, the past few weeks, we've been kind of splitting the line of talking about like, and Ron has been showing how like the Powerwall side of battery building and the automotive side are sort of cousins. And so, what other types do you have in your shop, or that you could talk about would be like, which one would you advise? Like, oh, put this in your Beetle, and then put these in your Powerwall.
Oh yeah. I mean, there are differences. You could use some of the same batteries on both, but traditionally, what's happening is like lithium iron phosphate is really good for home storage, right? Because it's safer, because that's not so reactive. The prices are coming down actually too, because they don't have cobalt in them. So they're easier to make. They don't need this super rare like metal or whatever that the other ones have. Also, they don't need to be super dense. Like the energy density can be low, because it's like, it doesn't matter if you put them in the wall. Usually there's you're not using that one for anything else, right? Where in the cars you do need almost every single inch and every single pound and stuff. And so so we have 2 of those, but I think a lot of my customers are buying car modules also and making storage applications, using them for storage applications. So they're making their own DIY Powerwalls with Porsche Taycan batteries, or with the Honda Clarity modules, or I mean, we have a bunch of them. We have Jeep modules that we just got a bunch of them in. So those are like really small. Some of them are set like the Audi IQ Q5, I think. This came on 13S. So they were perfect 48 volts. So you could and I did a video where, if you go to my YouTube channel, you see like I made like, they were super easy to install in a wall, and then connect them all in parallel, connect the BMS, and then that's it. You're done. You just made a 20 kilowatt hour Powerwall for like not much money, like $100 a kilowatt hour, which is way less than you could ever get any system. And they're super easy because they're all put together 2 modules already.
Nice. Do you currently have any Tesla Model 3 LFP packs in stock, or are those kind of hard to find?
I haven't come across those yet. So yeah, I think those are hard, because I think most of them were being manufactured in China at first, right? But I think now they're starting to bring some in, or manufacture some in here or something. So I have seen them, they start to pop up, but yeah, I haven't gotten too much of I think there's a lot of competition with the Tesla stuff, where like the other stuff is, like they don't know what to do. So I'm grabbing all this other stuff.
Yeah.
Nice. Tom had a question, I think, right?
Oh yeah. Hi
Tom.
guys, good to see everybody, the regulars and the new faces. Hi Jehu.
Hi, how's it going?
Yeah, it's going good.
This is the excitable Tom Summers. This is the VW guy.
Hey, yeah, I'm okay right now. Hey, but speaking of VWs, I noticed that Louis was out here on the West Coast, Jehu, and did you ever get any update on Louis's VW bus that he drove across country that you were so kind to hold his hand for that period of while he built his vehicle, which I thought was amazing.
No, I haven't talked to him. I did know that he put out a video doing that little car, right? What was the name of that car? So I don't know what happened with that. Either he might have sold that car or something, because I haven't seen it in a while, and I know that he moved back to England and stuff. So I haven't asked him what happened. But by the way, if you don't know the story on that vehicle, he was traveling to the East Coast through
Yeah,
the
better.
winter. And what happened was that like one of his packs just
Got wet.
was that, I don't know if it got wet. I think
No,
it
he was in a really bad snowstorm, and he made it all the way from Santa Monica to he was like on his last day to make it to New York in the middle of winter. He was doing it just like just like Jack did on the bus. He was staying at RV parks and plugging in at level 2s at night. And I mean, he made it almost all the way, Jehu, and then it crapped out. And now I heard some rumors that he might have contacted to Tolik's friend Brett at Solarola, and who was maybe going to work on that bus and get it back together or something. So
yeah. As far as I know, it was only one pair of modules that open circuit. And I thought it was so weird. Why would these battery modules just die open circuit? But now I'm like, it seems to be the thing that happens with those modules. They just die open circuit. They just, all of a sudden, there's no current going through a set of cells, and that's it. So it's not super rare. It seems to happen, because it happened to me with this one over here, and it's got early Tesla modules in there, right? And so, yeah, this is what happened. I don't know, and I don't know why it did that. I know that they weren't frozen. He was in the middle of going, like he was on the road. Like, that's so weird why it would just open circuit all of a sudden. And it wasn't out of balance, because we had the log to the BMS. It was kind of a weird failure that happened there on that one.
Yeah, and by the way, he came out to do a review of the Aptera.
The Aptera, yeah. I saw that one. I saw it yesterday. I saw it.
Nice. Super cool. So I wanted to ask you about these batteries that go open circuit. I remember you saying a while ago that that some of the Tesla cells had a cap and a fuse under the cap. Did I imagine that?
No, the early versions of the 18650s had a CID thing, which was like a metal that was touching, but if it would get hot, it would literally pop up.
Like a bimetal?
Like a bimetal, yeah, like that thing that from your blinker, right? And it would do that. And once it would do that, it would be open circuit. And so, early on, we were messing around with batteries, and we realized that if we drill a tiny little hole and you just push that little plate down, you can reconnect it, and then you could use it, right? Obviously, that's a safety feature. They had it there. They were trying to make them safe and stuff. But then there's the other thing, that most of the cells that are the 18650s, they also have a current collector. It's just like a little wire, a fuse wire inside that connects, to the casing and stuff. And so if you exceed a certain amount of power to those things, they could just, you can blow that little fuse inside too, or that little fuse wire, right? And so there's a bunch of reasons why these batteries, they might die open circuit. I don't know particularly which one of those is happening on these, but it seems to be happening on that build that I did for Robert Downey Jr. It was the same thing that happened on a couple of those modules. Now they shorted them out as they were handling and stuff, right? And so they shorted one, and it just went. And I thought all the outside fuse wires would be blown, but they weren't. They were intact. But the battery itself was open circuit. So I was like, what? That's
Did
crazy.
they get that on film?
What's that?
Did they get that on film when they melted that wrench, or what?
No, I don't think so. That was another shop that, they didn't know what they were doing. They should have, it was a bad deal, because they had me there for 2 weeks, and I built it just enough to make sure that it worked. And then they took it all apart, and then they were trying to put it back together, right? And follow a set of instructions. I mean, I did leave a book full of all the wiring diagrams, all this stuff, but they didn't know. They plugged in the BMS and in the wrong sequence, and so they burn one of the little BMS satellites and stuff. And then I could see some evidence that the arc one of the modules and stuff, and so it just kind of died.
Nice. So, what I wanted to get to was, first I had a question about the battery we just mentioned before that has a BMS on it.
The little,
the
scooter one?
R14.
Yeah, the scooter one.
Yeah, this one. So that BMS is usable.
Yeah,
Wow.
I mean, it works. It has like a 30 amps fuse in here, and I think it will sustain about 20 amps. Right.
Okay.
So
Yeah.
if you think about it, it's got 40 cells. So there's 4 cells in parallel, and you're doing 20. I think it's like 25 amps. So if you divide, 25 amps into 4. So you're putting about 6 amps per cell. So yeah, you're doing about 3 Cs on these cells, which they're totally capable of doing. They're 3,400 milliamp hours. If you exceed that, then the MOSFETs will open. If these get too hot, then the MOSFETs will open and cut power. It does have a separate circuit to charge. So if you charge through here, then it should balance the pack, right? If any of the cells are drifting. And it will also stop. It will open the MOSFETs here if you get above
the top voltage.
But it won't. It's not going to give you a report of like cell 1 is at 3.68 volts. It's all internal. It's doing its magic internally and not reporting out anything that it's doing. So,
Right.
Yeah.
Like
Now,
BMS,
if you
like
go
an Orion or something else that does the entire car, you're getting feedback as to every cell and what it's doing. So
Yeah.
On one hand, it's nice because it's modular; it just does its thing. But when it fails, you're not going to know why. If you have this embedded in a pack somewhere, and one of these BMS gives up because it's supposed to or because it failed, you're not going to know why.
It's just one string will stop working basically.
Yeah.
You'll have a 1.5 kilowatts less in your pack.
Because they'll be
they're all in parallel, or they're all in series. No, it must be in parallel then.
Yeah, so I'm series in 3, and then I'm paralleling all of them. So there's gonna be like 80 groups or 40 groups of 3 cells.
Okay.
What is it? 140? I'm doing 140, and I'm dividing those to 3.
You get so fast. I always lose you. But basically, how many in parallel are you going to put in of the packs?
So it's gonna be about 45 strings of 3 cells of 3 packs in series.
45 of those little things you're holding?
Yeah, 45 strings, 45 groups of 3.
Right. So 45 times 3, 140 roughly.
140 packs. That's gonna be about 60. What do we figure? So it's 475 watt hours times 140. Yeah, so we're gonna about 66 kilowatt hours. So
that's pretty good.
Is it a Hyper 9 system, or what's the motor?
I have an AC50, but yeah, it would work for the Hyper 9 and
So a lower voltage, not Tesla voltage. It's like 140 or 150 volts. So.
Yeah, it's 100. It's a 96 volt system, but it'll go up to 132, I think. So nominal's 111 volts, and that's what I've been running on that bus for 10 years. So I kind of know that system. I know how much amps it pulls, so this battery will be fine. It'll be
no need to reprogram your charger and all the other stuff. So
no,
changing your voltages.
Yeah.
So how many?
And then
go ahead.
And then the other systems that we have. Oh, I don't have them over there. I used to have a pallet over there, and I had those are the 1239s. So those are 144 volts. So those will the range of 40 cells in series works perfectly for that, right? So I'm like, I have a bunch of those systems too that we're going to use.
So how this new pack? How many different types of batteries have you had on the bus over the years?
A bunch. So I started with lithium iron phosphate. I had the Winstons, the 90 amp hour Winstons back in the day, and then
are
those the yellow ones?
Right, yellow,
ones. And then I retired those. Actually, I didn't retire those. I kept those in the pack, and then I parallel Tesla modules to it. So I used to have 30S lithium cobalt oxide battery, right? Modules, and then I had 35 cells of lithium iron phosphate, and I ran that for a few years, and it was interesting.
Wait! You can mix and match.
Yes, I mean that
Can and should are two different things. So
okay, so it was a very interesting experiment because you would see that they have different curves, right? Those are two different chemistries, but at the end, the voltages match at the end, at the bottom, and then at the top. But what you would see is that a battery would start pushing amps before another one, and then at the end, the other one would pick up and would put at a lower voltage because they have different nominal voltages, so they push power at different voltages, right? And that was very interesting. So if you were like at 80%, state of charge in one pack, you would disconnect. Like the packs would bounce at different voltages. But if you connected them, that there was always some kind of transfer that was going from one pack to the other one, depending on how hard you ran it and how, eventually it would all like stabilize and they would all sort of work each other out. And I ran these for a few years without BMS, without a thing. I would just be like, check things. And this is before I even had a thermal camera. I mean, a thermal camera would have been so much, so useful in those days. Those days we were like touching stuff and we were like checking with clamps and checking like what was happening. But I ran that experiment for a couple of years, and I used to make videos about it. And yeah, I mean, people just hated me because I was going against the grain. I was like doing things that you shouldn't do. And
how dare you?
Try it, I'm just gonna try it and see what happens. We'll see when it catch fire. Everybody says that I was gonna end up in flames, and I'm like, well, we'll see. I'll make a video.
how many times over the years have you had fires in your facility?
Never. Once.
Never.
We had one fire, and it was one of these little scooter packs, and it was the reason is because someone put it to charge, one of my employees, and they left their charging overnight. And then the next day we come back, and we were sitting there, and we're like, "What's that smell?" It just went in front of us, But that's the only fire. Like we've never had a battery catch fire. We never, and there
was the Jeep incident.
Oh, the Jeep was in the battery. The Jeep was
that was the controllers. I know.
That was the controller, and that was a fire. Let me tell you.
Oh,
Yeah.
that's right. Yeah, I remember that. The white male Jeep, right?
Yeah. Oh, yeah. That one
Was it
incinerated
outside?
that little controller.
And
And
It
we
was
never
outside.
figured out why, by the
Fire.
way. Never really got to. I mean, there's nothing to see after it happened because it was just charcoal essentially, right? So how do you diagnose that controller?
So when you had the mixed batteries, you were kind of like being sort of like mixed fuel tanks, like, oh, turn tank 1 on, tank 2 on, or not that quite simple.
It was actually simpler than that. It was just connected together, and I didn't.
Oh.
I used to kind of monitor it just to see what was happening, but after a while, I'm like, you just drive.
Now,
it wasn't an A/B switch. They were totally in parallel 100% of the time.
100% of the time, yeah. So no,
So-
there was
So
no like.
when you mix and match, am I right? You have to have those in parallel. There's no way you could do a series mix and match, right?
Oh, you could do a series. It will work for I don't know, for a few cycles maybe. It depends how you do it. Like, but it's definitely not ideal. You're pushing. Yeah, I guess you could design a pack that was like matching, and you could use it in series, but that's much
A lot of
harder.
it is the intelligence of the user.
Yeah, yes.
Jehu knows batteries. Jehu
Yes.
also has some spare batteries when these burn
Yeah.
out.
Yes.
Yeah.
And I have burned stuff, right? I've killed many batteries in my bus. In the early days, we had to bottom balance. And the reason why we had to bottom balance was because we had no BMS. And we would run our vehicles so they wouldn't roll anymore. Like you would, you're like, oh my God, I'm a mile away from my destination. And then you're like, I think I can make it. I didn't make it. And this was happening all the time. I used to do this like once a month. I used to run out of batteries and I had to like push my bus and stuff, and so that's the reason why we learned early on that we have to bottom balance the batteries, because if you didn't, they would die at the bottom. You would kill a few. And that's how we learned. It's like, why did 3 cells die? Oh, it's because they weren't balanced at the bottom. They were balanced at the top, and then we reversed, we put current reverse to them. So they just died, And we're like, what if you run in like where they're all perfectly balanced at the bottom? Well, they'll just all give up at the same time. Yes. And then none of them die. You know, they did suffer some degradation if you ran them down to like 1 volt, but you could wake them up. You know, you just throw the charger back on there and they would charge, and then, you know, you were good. You lost maybe a few cycles in there every time you did that, right? But I mean, I ran that pack, I ran it for many years, and then eventually I took it out and I did some tests on those, and they weren't that bad. They had some degradation. And that set of lithium iron phosphate batteries that I had on my bus, someone bought it from me, and then they set it in their garage, and then they used to charge their Model S with those batteries. So that went to even a second life after me, you know.
Yeah,
Even after all
reuse. You got to reuse before you recycle it.
Yes.
Okay, so that was the lithium pack with the added modules. What did you put in? So that was like what, 2.5 on your bus? What was the next pack you put in there?
So then the next pack, I just added more Tesla modules, the Smart for 2 modules. So then I made a whole pack of that. And then we were running that, right? And then after I started adding these little scooter modules, because I didn't have enough. And I would go to Octo, and then on the way back home, I would like almost didn't make it. And this is when my bus was running the best. Like I put like this upgraded suspension, and I was like, I was dialing it in and stuff. So it was running really great. And so I used to just, haul ass on the freeway, 80 miles an hour, and so it wasted a lot of energy. So I'm like, how come I used to be able to get like 160 miles, but now I'm getting like 90. What's going on here? It's like, oh yeah, because you're wasting all this energy by going, with the traffic of LA. And so then I started adding these scooters because I wanted to test it out. I'm like, can you run these scooter batteries on it? And then, I added about another 15 kilowatt to my bus in there, and I ran that for years without zero issues. And so that's how I know that it's going to be fine on this bus right here, because I ran them already, and I just kind of charged them, top balanced them, and I connected them in parallel with the Tesla modules and stuff.
That's awesome. What I wanted to ask you next was about the PCB board.
Oh yeah. Well, which one? I have a million designs.
Well, but like it's a unique thing. I just want to introduce it a little, because when you wire batteries up and you got you got to put your big cables, or you put your bus bars, and then then you go ahead, or you do and then you have to solder in all your BMS wires. This is a huge pain. And so tell us about the PCB development.
So let me see if I have. Oh yeah, I have one of these modules right here. I started,
and I have some photos to share that we did, because it really cuts down on the wiring.
So I started with this one, right? We needed a way to put like a bunch of 18650s into modules and build them into packs. But yeah, it's you have to put them together, and then you have to like spot weld them, and then you have to like run a bunch of cables and stuff. And I thought, like, there's got to be some way to do like a modular thing that any dummy can do it, right? Like someone that doesn't know anything about batteries should be able to follow some instructions and then just put batteries. I think about it like replacing your batteries in your remote control. It's like any dummy can do it, right? Like they don't need to, as long as you put them in the right direction or whatever, the right polarity. And so this was the idea behind this. And we started making these, and then you stack them up, and you can make a little pack. This is a 1-pack 7S 1P, and then you stack it on top of this one. Now becomes a pack 7S 2P, and you can keep going. And then the little standoffs here are made to connect and transfer, conduct the electricity from one to the other one, and then you connect all the balance wires through this little set of like ribbon cable. Right, this transfer from one to the other. So essentially,
that's really cool.
And they fought me on this. Again, everybody said this was a dumb idea. It was crazy, and but I did it anyways, and we started selling them. And then I made this project open source, and then people started buying their own. And so then, I think now we're like almost 200,000 of these little boards that are being made at this point. And I know that because I ordered myself. I ordered about 100,000 of them, from the PCB makers, and then I sold them through my website. But then other people were just using the Gerber files and then downloading them, and then they were building their own, and we get pictures of their setups. Some people went crazy and built crazy setups with those, right? So from that, went on to like, okay, how else can I do, or what else can I do? And so we got a bunch of these prismatic cells, right? These prismatic cells, like there's a bunch of like this, and I thought, why can't we use a board that has all these wires and it has all these things so that you can connect them? And see, this is what that Ron is linking here. These are some lithium iron phosphate cells that we got. A giant load is like 80,000 of those, so about 10 truckloads worth of those. And they needed a way to make bus bars, right? And so I thought, why don't we just make a big board, and then you can just have everything wired through there. And so that's
the board is the bus bars.
The board is the bus bar.
There
Now
you
those
go.
can push a lot of power, like 400 amps, right? And so we did make aluminum bus bars that go along with that. You see those little circles? That's where they would go. And then I think you put those on the bottom, right, Ron? I think we were putting them at the bottom at first, and then we changed the design, and we're like, let's put them on the top. So there was a few iterations there that went on, but this would makes it really easy for people to put their BMS, right? There's this little connector, that green connector right there, where now you just like little screw terminals, and they're all labeled. You just connect their little leads from your BMS, and then you're good to go. The compressor
saves so much time.
Well, speaking of
saves so
time,
much time.
it's amazing just how fast Jehu's iterating here. Like that. I mean, I remember seeing this demo board at last year's bus debut, and you've already done what, 2 or 3 iterations since then?
Oh yeah, I got like 20 designs for that, because people kept asking for everything, right? Like, can you make a 4S one for 12 volts? Okay, let's do that. Can you make one for 36 volts? And I'm like, yeah, we can do a 36 volt. Can you do a 24 volt? Can you do one long? Can you do one fat one? Because those batteries can't fit in my thing. So yeah, I just like, okay, I can do it. It takes. I already did all the mechanical on the cells, so I'm like, I could just rearrange this stuff. And
The only problem is I still need my glasses to see the BMS wires that have to go in the little clip.
Well, listen, that's you can't make them much bigger than that.
Yeah, true. Yeah.
That's user error right there.
Oh yeah, totally. No, but it's cool. It's labeled really well. It's great for education. I was able to use it very quickly. And think about the cabling and crimping, the crimper tool, the cabling. How much money did I save? When you buy one of these boards, it's all figured out, and you can see everything on top. It's all labeled, which way to go. You're not going to make a mistake, which was pretty cool. It's great stuff. That is pretty cool. So I had another question about the BMSs. Well, actually, before we get to that, what's your latest PCB board iteration? What's going on?
Well, so now I'm doing boards for specific battery modules, right? Like, and Kevin is showing one right now that we made for some custom battery that he had or whatever.
Right.
Like a round.
This bike had a round battery in it that was like a spiral thing that somebody had put together, and it was super sketchy. And the BMS wires were like put on there with, bubble gum and snot. It was a terrible thing, and it failed, of course. But Jehu's like, oh, I got something just like that. I'll just go, while I eat my TV dinner at night, I'm going to go and just, design you a new board. So he did that with this.
Yeah.
It required 18650s in a line, and then using bus bar to zap them into place.
Yeah, nickel strips through there, and then you're supposed to spot weld them in there, and then spot weld the cells to the thing. But you do have to make some kind of a jig to hold the cells.
Yeah.
Right. So in that area, and then now you can set that in there and then do the spot welds.
Yeah.
So
it would have worked. And I started to make one, but I never finished. But this is a top and a bottom, basically. And it would have been that battery sandwich and the BMS connectors and all this. This is the kind of stuff you could do with PCBWay and the tools that are out there that are basically free these days. And once you have a good design, you can iterate on that pretty quickly. So
yeah. So the last one I did, interestingly enough, it's a pack that EV West sells. They have this like LG pack,
Oh yeah, I've got some of those in my garage.
right? Okay, so he, Bream was like, "Hey, can you help me sell this?" And I thought, "Yeah, this is great." It's a 13S pack. It's 48 volts. It's great for like e-bikes or high performance stuff. I'm like, the only thing is that people are going to be like, "How do you install the BMS?" And I'm like, "Oh, yeah, it doesn't have a BMS. It's got the connectors in there, but it doesn't have BMS." So I made this BMS for that. I designed this, and all you have to do is just connect the two things, and then connect your BMS in here, and then connect those two wires in there. Now you have a integrated BMS. And then I thought, but this is kind of dumb because this BMS only does like 50 amps.
Is that
and
a
this
daily?
A what?
Daily?
Daily, it's
Yeah.
now it's a knockoff of, or it is a daily. Yeah,
It is
okay.
still, yeah. But then I
Okay,
thought
okay.
this pack can put out so much more amps, and I'm basically throttling it right through this. So I thought I need to make a design that you can stack maybe BMSs, and so that's what I did here. I just picked another BMS, and then you could, these ones you can stack them, and then now you can do 100 amps, and you can put a third one in there and do 150 amps if you wanted to. And so I thought maybe this is going to be the thing for this pack. It's going to be, and so that's the last design that I
Nice.
have on the
I
BMS
have
right
those
now.
packs, and I've tried to decode that wiring that's on those Samsung packs and try to figure out what was, and it was just too confusing. So this makes it great. You just plug it into your board, you plug the BMS in, and it's working. So
It works.
you don't have to come up with the connectors yourself and
Yeah.
do the wiring. It makes it really nice. I'd
Yeah.
like that.
Jehu, are any of your BMSs that you work with, are any of them active BMSs or are they all passive?
Well, it depends what you mean by that. So I think what you're asking is if any of those balance in an active way. And
Right. Yeah, we've been talking recently about how, like, most BMSs will just kind of burn off energy to balance the pack. But lately we've been talking about these ones that will take energy from a high cell and give it to a low cell.
Yeah. Now I think there's an application for that, I think, but most packs don't need that. And the reason I tell you why is because no two cells are alike, right? And that's why you have to balance them. And you have to choose, like, balance them at the top or balance them at the bottom. At the bottom doesn't make sense if you're using an active system that is, taking care of your batteries. At the top, it makes more sense, right? Because that's when you're charging. And so that's where you want your batteries to start. And so when you're doing that, like these active balancers, they're trying to balance all the time, right? So they're trying to balance like at the midway of the charge curve and so discharge curve. And so you're just kind of wasting your time trying to balance cells there, because then when you charge all the way up, they should if you top balance the cells, then they all should like even up at the bottom. So you should be only balancing at the top and at the edges of the charge circles, right? Now, there's some applications that might require that. If you're using your pack, like for example, if you're using like a 12-volt battery that is lithium iron phosphate, and you're always going to use it in your car, and your car is just going to always keep your battery not really at the top, but just using it in the middle. And that's where you want your cells to be balanced. Then that's what it makes sense to have like an active balancer that no matter what's happening, it's always going to be in the middle, right? Because you turn your car on and it's going to charge it, it's going to keep it there. If you use it like your audio system when your car's off, then it's going to lower a little bit. But as soon as you turn on your car, it's going to charge it right back to this middle section. So that's where it would make sense to do it. But I think even the most advanced, I just tell you an example. We have Taycan modules right now, and those have an integrated BMS. So that module is sealed and it's got one little BMS module in there, right? So all it is just a balancer essentially, and it does it. And I'm looking at it and I'm like, oh yeah, this is passive. It just has a bunch of little resistors and stuff. So even those that run, this is a system that's crazy because it runs 800 volts, right? And so even those are just balancing with like little, just burning, essentially burning energy at the top. And then all that is connecting a module to the next is just like a CAN communication, right? Some one little wire that has 4 wires and they daisy chain, like 2 wires daisy chain from module to module. So even those, the most advanced BMS systems are just basically passive. They're just burning energy at the very top. And by the way, if you have a quality battery that is well matched or well designed, you don't need to burn a ton of energy. It's like tiny amounts of energy that you're moving or burning.
Got it. You know, I got a question about BMSs. You look like you got those stacked up. So
Yeah.
you have BMSs, you can put them in parallel and series, or is there some difference there?
Well, there is some difference. You could stack them in parallel, and I've done that all the time. And people say also the same thing, that you should do it. And I'm like, well, let's try it. And then I've been running these successfully for a long time. Everybody thinks about the problems instead of like what would happen if it would work, right? There are some problems that could arise when you have this, right? Like, for example, if one of them turns off, then all the entire load goes to the second. But then all that's going to happen is going to turn off because they do have current sensing thing, and so they turn off, right? But it could start a cascading effect, right? And so they're like, is that a bad thing? Well, maybe it is, but it's not the end of the world. If one of them has a reason to stop, then the other one is just going to follow suit, basically, right? When it comes to putting them in parallel, that's another thing that people say, like, well, they're not designed to do parallel. That's true. They're not designed.
Oh, you mean series or?
Series, yeah.
Yeah.
And yeah, the BMSs usually are not designed to run in series, right? But I've been running them in my bus for years, 3 in series, right? These are designed to run like at 40 volts, right? Fully charged, but I'm running at 111, and I'm like, okay, let's see when they're gonna blow up. And I'm like, they've been blown out after a couple years. I've been charging them, discharging them, right? They just follow the rest of the pack, and they never gave me any trouble. So I'm like, okay, it seems like I can run them. It's like I can run stuff. Sometimes you can run stuff without the outside of the parameters that they were designed to work, right?
Yeah. So that pack you're talking about, the R14, you're gonna run that with the BMS, or are you gonna take the BMS off?
No, so the test is to run it with the BMS in there.
Wow.
Yeah, just leave it in there. I mean, there's 140 little BMSs that will disconnect.
There's an advantage here that we should mention. It's because you're getting a pack that's already put together and it has a BMS, and you're not like buying an Orion or a Thunderstruck and then wiring everything up. You're gonna use what they got.
Yeah. There are some benefits to that. It's really cheap because it's there already. There are some downsides to it, like not having granular data about what L groups are doing, or which, you lost some strings for some reason, or, all that stuff, right? You're just gonna be flying blind, You're gonna be basically driving like you were all those years ago. It's like, oh, let me see how it feels. Do I have the entire pack? Let me see.
Right.
Yeah.
Oh, that was my, what I just pointed out before, is like, you just don't know if one of these fails. Now it's probably in a metal box and underneath the floor or something, and you have less power, you don't know why, and just one of them failed, you don't know. So
do you have to, when you connect them up, do you have to connect with cables that are the ones that are just on there, or do you use the total amps? Like, do you need a wire thick enough to deal with the total amps on each module?
No, I mean, because each module group, it's only going to be supplying about 20 amps, right? So as you're going down the line, if your battery starts over there, they could be thin wires, but as you're making your way up closer to the load, then your wires need to start getting bigger. What I did on my original, I was running 8 groups of the Tesla Smart for 2 modules, right? So I was running 8 groups of 2 modules, right? And so that's what I did. I used I think it's like gauge 6 maybe, or 8, and I just used those. I think it was 6, and then at the end I had 8 positives and 8 negatives, and I just put I crimped a lug, like a, what is that called? The ones that you put together, the bud connector.
Oh yeah.
Right. And so that's where you combine all those groups. But after that, it just went into thinner wire, 6 gauge wire, because each one of those groups were also only, putting out about 100 amps, not max, at hard
Yeah.
acceleration going uphill stuff. For the most
Wow.
for the most part, they were just supplying about 40 amps or something like that. And
Cool. Yeah, I mean, that's awesome. So basically, in summary, because we're going to wrap up, we try and make these about an hour, and but we'll hang out afterwards, whatever. But yeah, I mean, in summary, there's so many options. You don't have to use like Tesla cells, and you don't have to use cells that were meant for a car. You could use these scooter batteries, and they already come with a BMS.
Yeah, but I do have a bunch of modules for cars. We have the Jeep ones that we just got in. We got the Taycans that we just got in. We're doing Fiat modules. People are buying a lot of Fiat modules. We even have some Alfa Romeo that we got in. There's Chevy. What is the Volt with the B? Those
Shaped battery.
Yeah. We're doing a lot of Hyundai ones. We even sold a pallet of like Nissan Leaf modules. Yeah, so all these modules that are great, like this ones are the Jeep ones. They're my favorite modules right now. Check
Those
these
look
out.
like LGs.
I was literally about to ask you. So, what is your favorite / most reliable battery, and what's your least recommended, least reliable battery? Well, not one that you sell, because we don't want to.
Well, I think I don't know. I think LG Cam has a lot of batteries that are like suffering recalls. So like if you're buying a new car, I've told people, it's like, oh, what kind of batteries do you have? Oh, LG Cam. I'm like, I don't know. But they are replacing battery packs and stuff. But I know Samsung cells, for example, those have very little recalls. And then after that, I think like when it comes to like design, I think these are some of my favorite ones right now, because this is 2 kilowatt hours. It is really small, really tight. And the thing about this is also a proprietary BMS board, right? It's like a little daughter board, and so you connect in here, and it's got CAN communication there. I can take these screws off. In fact, I designed a board for here. Now I just end all those in a custom connector over here. Now you can build a pack that you can have granular data onto like every single cell.
Yes.
Right.
Because nobody's figured out how to talk to that BMS yet, or it's
not yet. And I don't know if they will, because this comes from like a car that is kind of it's not like mass produced. So this one's come from the Jeep Cherokee and also the Jeep Wrangler. But there's also a 13S version of this that comes from the Audi Q5.
That's a good price.
Yeah. So I'm buying them really cheap, and I'm selling them really cheap. I don't want to have these in my warehouse, like I have a pallet right now with 200 of these modules. I don't want to keep it there. I'm like, let's price them so they move, And
what's the chemistry on these?
This is NMC, right? Like regular. I don't have any information on these. This is I kind of look for them. I can't even find anyone that has taken a Jeep pack apart. Usually you can search and you'll find like Sandy Monroe that took one apart, or you'll find some car dismantling guy that took one apart, and you'll show you. There's like almost no info on these because they're so new, and I think the cars are like low volume, so these are not going to be like, these car companies are kind of struggling right now to sell electric cars. It's not like Tesla's pumping a bunch of them out of there, so the information is kind of limited. Oh yeah, that's the pallet that I bought of them.
Nice.
And
wow. And those are Samsung?
Those are Samsung cells. Yeah.
Nice.
Samsung cells, and they push about 400 amps because they are in full electric cars, but they're also in hybrid cars. So in the hybrid application, they have to push a lot of amps. But I think Jeep was smart enough to say like, okay, we're just gonna get a battery that'll work on our most demanding application, but it also just use it on the regular EVs, right? So I'm like, oh, great, because now we have these little modules they could put a lot of amps. And they're actually, the energy density is pretty good, right? Like I think I worked out the energy density is like almost as good as the Tesla ones.
Wow.
And there was before us to like, what was the capacity? We literally had to test it here ourselves in-house to see what we were dealing with.
And it has its own BMS, or you have to add one?
So this has its own BMS daughterboard, but it's proprietary, right? So I would have to someone else to figure it out. But it's removable with screws, so I'm making my own breakout boards for them.
Oh, dude, that is awesome.
Yeah.
How much does it weigh?
Handy.
This one, I think I put it in there. Let's see. I think if you scroll up, oh no, these are just the pictures. I think where like the info is.
Oh, sorry, I got to get out of that.
Yeah. What does
Okay,
it say on
yeah.
the bottom there? Like on the bottom.
Yeah.
Yeah, go to the bottom.
Pack specs. Here we go. Voltage capacity. Voltage capacity.
I didn't put the weight,
Okay.
but I think
All
it's
right.
like 25 pounds, maybe. I think I can look it up on my end over here. Let's see. If you go to the backside, I guess I have to work better on that because I have to figure out the weight for all these products so that when you order it, it's like I know how much the system knows how much to charge you. But for some reason, it didn't make it on the front side where like at least the size is there because that's another important thing that people.
Oh yeah, totally.
You can divide that.
Yeah.
You can figure it out with the math.
Yeah, we could
so-
do some math there from the density.
Yeah, it's got the energy density. So
So it's 35.
Yeah, you've got energy density there. Anyway, that's really nice. Those look handy, and that would be good for a Tesla motor system too, because you can get 96 pretty quickly with that 96S.
nice.
Yeah. These are very popular, and people are buying them. Like we've sold, I don't know, like 50 of these things already and stuff. So that's very exciting. I'm finally getting like all these automotive modules that are pretty nice, and they're cheap right now. I think as this progresses, like for example, the Pacifica one,
Mm-hmm.
right? That one was one of the first ones that I started messing around with. Those like 7 years ago, and I started making videos. And you go to my channel, it has a lot of views. So now, when I go to my supplier, the Pacifica, there, he wants a lot of money for them because they're popular. Because people are using them for conversions. Right? You go to a show, and half of the conversions are using those. And I'm like, why do you want so much for these? And it's just I have like 3-4 guys that will buy them if you don't want to pay whatever I'm asking for them. Right? But when it comes to the Jeep ones, he's like, I got nobody asking for those. So I'm able to negotiate like a lower price for those.
Which is funny because both are within the Stellantis umbrella, but they're different. Yeah.
Oh yeah.
Get
No,
up.
these are like really capable batteries, really high quality,
It's the old set.
but they're not. They don't have an application for them yet. So cheap.
Is
So
this
cheap.
this is the Mercedes smart car battery?
Yeah.
Oh, you guys there?
Yeah.
Oh, okay. These are the smart car batteries from back in the day. This is all sold out, right?
This is but these were the ones that were on the. Does it say there? Oh yeah, this is a Mercedes. This is a Mercedes B class.
Yeah. Okay, I
The
got you.
modules look the same, except these are 24 volts instead of the ones that I had in the bus. Those used to be 15S, so they were like 55 volts. Yeah.
Yeah,
But
that's cool.
I do get them. My supplier keeps getting them. Like I know he's got a few of them right there. So I think this week tomorrow I'm gonna go and get more of the Porsche. I'm gonna clean them out on the Porsche Taycan ones that he's got there. Because a guy just cleaned me out today. He just bought like $10,000 worth of modules. So I'm like, hey,
All right,
more of those? Yeah.
Yeah, those look really nice and pretty durable.
I have a
only-
dumb question. Oh, go ahead. What were you gonna say?
The only
okay.
challenge with that is that you'd have to figure out the BMS because it's inside. And so you can't replace it. I mean, unless you cut them open. I do have one that is cut open here. You see that?
Yeah, I'm not cutting them open.
But somebody has figured it out because there's a BMS that I linked to there, and that guy has figured out the CAN communication from. So
Yeah.
Well, the thing about the Taycan cells that's impressive is that they engineered that car to do hot lap after hot lap, and it's supposed to not suffer performance. So if you want to put some juice through your conversion, and you can figure out the BMS, that you want a performance conversion, that might be a good option in terms of resilience.
yeah, and this is the gentleman that has figured out the CAN communication. So you basically buy that little board, you connect them to all the modules, And the thing about these modules is it's really it's smart the way they did it, is so you don't have to run a bunch of like wires, right? Like to an outside BMS, because now you're talking about a car that has 800 volts, right? So it's got like 33 of these modules in series.
Wow.
so that starts that's like another level of thing. Everything has to be special car because you're above 600 volts.
Okay, I got a dumb question. So the battery looks really in good shape. Yeah. Does it come out of like failed production, or does it come out of crash cars?
So
I understand the crash car, that's not a bad thing because it's still inside the box, just like a Tesla. Yeah. But is it coming from like where does it come from?
Yeah, so it comes from everything. There's wrecks, they go in there. There's recalls. There's a decommissioning. Sometimes they'll just like not want to support a car. There's pilot programs. This one's in particulars, the story is that my supplier said it was a train with a bunch of Taycans and it derailed and a bunch of them burned down to the ground, but a bunch of them were salvageable, some parts and some motors and some stuff. Wow. And so Porsche just sent them to be recycled. And so these batteries, usually they don't want to recycle them because it requires an extra step because they're hazardous materials. So all those packs were saved, but I want to say something like 60 Taycans were involved in that.
Wow.
And
that's
so
big insurance claim. Oh my God.
Yes.
Wow.
And
but I mean, that's so great because, you know, recycling, as good as it is, it's still the last resort, really. I mean, well, the real last resort is throwing it away, but last resort of, you know, you gotta expend more energy and expense to break down a battery. But if it's still usable, it's better to reuse it for whatever application it's going to be. So this is awesome that you even though I know this is a business for you, it helps the cycle life of these materials.
Yeah, definitely. Yeah. That's the best thing you can do, reuse it. Like in this case of these modules from the Taycans, they're like 0 miles. They build them, they put them in cars, and they were on their way to the showroom, and boom, you know. So it's like, so this is going to be kind of rare. I don't think we're going to see this ever again. So all the next modules that we'll see from the Taycans are going to be from Rex. So they'll have some miles in there. They're going to be from, I don't know, some other things, you know, that happened to them.
Got it. So
mismatched capacity on all those, but because these are new, they should have the same capacity.
Yeah.
Real quick, this is Griffin. He's a neighbor.
Hi, Griffin.
He does microgreens.
Microgreens.
Yep. Believe it or not, like broccolis, like they're like this tall, like an inch tall, and it's got the same nutrients.
Yeah.
Oh, there you go.
Vertical farming, and it's pretty amazing. But basically, the last question I wanted to ask is, we're going to run this class. My target date for New Jersey, and it'll be the test run. If it works here, we could do it out there, Jehu.
All right.
Is August 5th through the 9th, and we're going to do day 1 fundamentals, just learning how power electronics work. Believe it or not, the voltmeter, amps versus volts, relays, all the regular stuff. And then day 2, we're going to populate a board with all your stuff that goes in the car, and put the batteries on the board and whatnot. And then day 3 and 4 is put it in the vehicle, but we're not going to customize it. We're just going to take the board and put it in the vehicle. That's how we're going to save time.
Okay.
Yeah.
All right.
And then the last day is tune. Now, I've been told that this is not going to work out because it's a lot to do in 1 week, 5 days.
1 week.
Yeah. But as far as batteries go, you did recommend a battery to me a couple days back.
Oh, yeah.
What battery was that again? I want to pull it up and we can talk about a battery because I don't need a lot of capacity.
Yeah.
I just need the voltage.
Yeah.
I need power because I want to go up a hill and do a burnout. I want to do a burnout and then the class is over.
Yeah.
You know.
Yeah. So the Honda Clarities.
Honda Clarity. All right.
Those are from actually those are the same thing. There's different versions of those cars. Yeah, I think you might have to punch it on top because I think that's like an old listing. I've had those for a while. Honda
All right.
right there. I have them on
There we
camera.
go.
I'm tired of just looking at the pallets.
Okay, so I was going to try to say this off camera, but basically, Johnny's out for a run right now. But he said, Jehu, he wants to buy your BMAX clearance cells, a bunch of them. So save some for
Wait,
Johnny.
these are the batteries I'm
Oh,
using for my class. You
Save
can't have
some
them.
batteries for Johnny.
Oh yeah, we have more of those coming. There's like my supplier he's breaking down cars right now, and it's like a pallet. I went yesterday, and he's like, "Oh, I'll come back for next week for those." I told him. Yeah. So those are
But
coming.
you
It's just
seeing this? Look at that 400 amp burst.
yeah. It's because this is this is designed to be in a little pack and push a car, right? Because it's from like a hybrid and stuff.
Right.
So, but it also was from I think there's another version of the Honda Clarity that it's also like a full plug-in car, electric vehicle. So they also run the same pack of like in a full pack version.
Wow. And that's a Victron system. And I've been doing a lot of off-grid stuff.
Yes.
And I've been learning. We did the Victron Multi Plus 2, 120 volts, but we did 2 of them, and then they're running 240, 48 volts.
The cool thing about the Victrons is that you have a wide range of input. So these are not 48 volt batteries; these are 44.4 volt batteries. So you need the extra little range, to set the voltage so it doesn't overcharge them or over discharge them. So I think this is about the only, maybe one of the few like inverters that will run these 12S automotive modules without problems.
And what do I do about a BMS?
I would say, yeah, get get the ones that get the lithium one. We have the cables right there, so you'll be able to connect to every single cell. Actually, we're making these right now because we have more modules than we have connectors. But now they're saving the connectors. At the beginning, they had pallets and pallets of these, and I'm like, where's the connectors? I can't find them. And they were like, oh, they basically just put them in a pallet and they send them to the scrapper essentially. And I'm like, it's like it's impossible to find these connectors. They're kind of like custom made for Honda. Those
Yeah.
cables.
Got it.
Yeah.
Cool.
So those are
so
scale.
I'm going to send you an order. I want to, because these look really easy to work with.
Yeah. And if you're doing what system are you going to do?
I would like to do like a net gain. I guess I would do the, do you think I should do the high voltage or the low voltage?
I mean, it's the only difference is you'll need one more module. You can run as little as 6 of these modules. You have full power. I mean, you have 400 amps, right?
Wow.
And then, or you could do the high voltage and do 6 modules or 7 modules. How much does that work? Yeah, 7 modules, right? Oh yeah, and there's this is a charger to charge a single.
Single. Okay.
Yeah, when people
So
buy
that's
like a
good 'cause
single
they-
one, and they ask me about that.
Wow, it's got an XLR plug. That's cool. That's a microphone plug.
Yeah.
Yeah, a lot of batteries use that. The Chinese ones.
That's awesome.
Yeah, I'm surprised
you
that I
got-
didn't find a 12S charger because that's not a very common pack, right? Oh yeah, and that's when I was doing some tests and stuff. I kind of record all these tests and publish them.
Yeah, that's a good idea. Did you put is that what's inside of it?
Yes, essentially it's a different version. Like this is a studded version of that cell. That cell in there is like a one that is welded together.
Right. So you would only need what's the capacity?
About 25 amps, I think, amp hours. So
Okay.
it's about 1.1 kilowatt hour per module. So
the
you would
minimum,
need,
yeah.
right? So if you're running on a 96 volt, so 6 times, well, what is that? 72 cells? No, you need 7. What is that?
So what's my oh, okay. It's 12S.
Yeah,
okay.
12 cells.
And I need 150 volts, right?
So it'll be, if you use 6 of them, it'll be 72. So times 72, right? Times,
72S.
no, 72. Yeah, 72S times 3.7. So you'd be a nominal that's 200. So you actually need to less than that.
Yeah. I only need 3, right?
3 times 12. Yeah, I think so. That's 36. Yeah,
24, 36. That's
Yeah.
perfect.
times 3.7.
So I just need 3 of these and I could run a car.
Yeah,
Not for very long, but yeah.
I have a very large for around the corner. You say you just want to do donut? Did
Yeah.
you say donuts or donut?
Donut.
More of a
No,
crawler.
but remember I told you last week you would need a minimum of 6. So you would probably like parallel two groups of these. And then you
Oh,
get
okay.
15 watt hours. Then you could get, I don't know, like that's like 15 miles or, depending on how big and heavy your car is.
Yeah.
Yeah, that'll
What and so wait, help me figure out what's the capacity again for each one is
it's
Kilowatt
25
hours.
hours. So about 1.1 kilowatt hours. I did the math.
1.1 kilowatt hours. Oh, okay. So if you only had 3, you'd have like 3 kilowatt hours. That would only give you like 9 miles, maybe.
Yes. At
That'd
full
be- it's
power.
about 3. Yeah.
But that's
And so
what you were saying. You just needed a cheap battery, the small battery that you can put in there. And you just, I'm like, this is the perfect one. It's super
what's
cheap.
the-
$60.
About 3 miles per kilowatt, right?
About, yes.
That's the yeah. Cool. This is
Yeah.
super cool. I'm excited, man. This is great. I like all the options you got it for us. And and what about the BMS for this? Did I ask you that already?
Yeah, get a dilithium one from
Oh, okay.
from
Yeah,
EV
yeah,
West. Sell that one and
Got it. All right, well, let's wrap up the recording. This is awesome, and I think this is a good episode for options. Talik, talk to me. What do you got?
Well, I just had a couple last minute questions for Jehu. So, do you have any current builds in progress, and what's your next show you're going to?
oh, that's interesting. I do have a current build where actually that was used to be my daily driver until I killed the battery.
The 21 window down below there. Okay.
Yeah, this one right here.
Oh, you're in your loft. That's cool.
Yeah. I'm in this is the bottom right here. That's my truck over there. So that truck right there essentially killed my bus because I parked my bus and I never turned the maintenance switch off on this. So that sat for like a year. I never disconnected anything. And I just killed my battery because I just abandoned it, right?
That happens to gas vehicles too. My Ranger got killed because I got a Tesla and I stopped driving the Ranger.
Yeah, that's what kills our buses. So we're
You gotta
changing
drive
those. So we're putting those scooter packs on that one right now. But then, we got a few more other ones that we're working on over there. I built this rack system here so I can stack them on top.
That is so cool. I remember seeing your post about that. That's awesome.
But then the next one is gonna is down here. It's like another one down there. And I got several of them, and we're gonna try to use probably several different batteries in here so that we can kind of promote the different types of batteries we have.
This is like Tom Summers' heaven. Oh,
And you know who just ordered batteries for me right now today? Maybe Tom, maybe you know him. Look, I was looking at the name and I was like, oh, that kind of sounds familiar, but not really. And then I looked at the thing. I made an order for Max Terrell. Do you know Max Terrell?
What?
Maximilian Terrell, and he's from the Thing Shop in Chandler, Arizona.
Yeah, I know the name. I've never met him.
Okay, so I think he's probably gonna put those on a thing. But for those of you who don't know, the Thing Shop is like probably the only store around that will sell you parts from a VW Thing. It's kind of a rare car. They're like the best source to get parts, right, and stuff. I think they're working on an electric one over there or something.
what's the name of the shop for the Volkswagen Thing?
Yeah, the Thing Shop. It's the Thing Shop.
Oh, the Thing Shop. Okay.
Chandler, Arizona.
Yes. So they're working on it. So I think those are the next projects. We're gonna probably be coming up with like 3 or 4 of these buses. One of them is painted down there that is gonna be all nice, and then I got mine that are kind of ratty or whatever. But I was having some crazy ideas last night that maybe what I should do with this really rusty one right here
Uh-huh.
maybe make plexiglass panels and then have like a see-through bus so that you can see where the batteries are at and where the motors
Oh,
at.
absolutely.
Like a working car,
X-ray bus.
you can see where the battery boxes are, and I can show them to people. Like, you see those modules right there? Those are where you put your batteries. This is where your motors at. This is where your contactors are at and stuff. And I'm like, why don't we do that? Like that?
Yeah,
that's
do that.
a perfect candidate for that. You
Yeah,
know?
we need to do that with the EVLC because anything that's educational, you need to be able to see what's in working. Yeah.
Yeah. I think
Kevin said it. He said the X-ray bus.
the X-ray bus. There you go.
X-ray and X-rated.
I think we need to like tap your expertise on how you built your shop out, because this kind of, having extra vertical space would be awesome at the EVLC to have a whole nother work area with the loft you have there and all that.
Oh yeah. I mean, I pay a lot of the rent is going up here. I used to have 4 of this base, right? And each one is going about $1,000 more every time I renew the lease. So I thought, I can't be paying that much money. I gotta build some kind of thing. And these ceilings are like 24 foot high. So I'm like, what am I doing? So I just thought this idea, and I'm like, these racks can hold 20,000 pounds. So I'm like, a bus is only 2,500 pounds. I'm like, we should be able to. So we just welded some of these together, and yeah.
And are you using a forklift to get them up there or what?
No, I have winches on every corner.
Oh, okay.
And I have a battery up there. That's the lithium phosphate battery. And I just have a little controller on the bottom, and it just goes right up. And then once I
There's a
get where
whole video about this.
Yeah, I do have like a little, I did like a little story or something about it. Yeah.
Mm-hmm.
I wanted to do like a full video, but it's just too busy. I got set.
If you need a videographer, let me know. I mean, I know you got all the good equipment, but I'll come do a video on it.
Oh yeah. There you go. I'm trying to set this place up with cameras so that whatever we're doing here, it's just being recorded. And then one day I'm like, oh, you know what? I'm going to do a video about this thing that happened. The fire, or whatever, or when we got it running, and I'll just go down to my thing and like, oh, here's that camera and then this camera. And that's the dream right now, to have cameras running 24/7. And then whenever something happens that I wanted, I just go back, grab the footage, put it on my my editor, and done.
With the overhead, like Casey Neistat, the overhead cam.
Overhead. I want an overhead, not only just an overhead, but a moving overhead, like a slow, so that I can do time lapses and it's like everything's moving. I want to do one that goes up and down, and they're just running in circles.
A robot. You need a robot arm.
Yeah, well, I can just run a wire across my thing and just put a little camera that just goes back and forth all day. It's like. All right, crazy ideas.
Yeah, the problem is when it happens on the other side of the room, you're like, damn it.
Yeah.
That didn't happen over here. Yeah, that's true.
Nice.
Yeah, so
right,
I did put the camera over there. Like, oh, that's my custom made Volkswagen. But see on the top there's like a little camera. So that's a camera in there. I just gotta wire it, and then it's kind of like a security camera, but it shoots HD, and it sort of kind of works that way that I want to. Like, if I ever wanted to go and get the footage, I just look through the app, and then I was like download it and stuff. And so I'm halfway there.
All right, so what's the next show you're going to, or you're presenting at, or whatever?
Well, I don't really know, because we're working on this. As soon as this is done, I'm hitting the next show. I mean, I just passed all these Volkswagen shows. Just passed, right? Tom, did you go to all those?
I was in the middle of cataract surgery, and I did both of my eyes, so I missed out on a bunch. But I think I've been to enough in my life for several lifetimes.
Okay.
Yeah, just briefly though, I just texted Ron some photos from the past. Do you remember that time that we were doing the 2-cycle engine fly arounds in the back 40 there?
The 2-cycle engines.
Yeah, and Michael came up with an electric. I don't even know what you call those things where you fly. You take off running and you fly and you land on your feet.
Yeah. The hang gliders, paragliders.
Paragliders, yeah.
Paragliders, right? Yeah.
And by the way, I saw your brother in one of the videos there. Give him my regards, would you please?
Yeah. Which one? Which brother though?
Oh, Saul.
Saul, yeah, he's here. He's here with me. He's working on that bus right now.
Yeah, we're so happy to see him come off the mountain.
There you go. Yeah, he's gonna finish that bus, and then we're gonna start working on another one, and yeah, we're going through all this. Yeah, it's gonna be cool. So I'm also getting into like recycling all the, because all these battery packs, by the way, from the cars, they have all these like contactors and fuses, and they have all this stuff that we used to pay hundreds and hundreds of dollars, right? And now there's like, I go to my supplier and he's got gaylords of like contactors, and I go, "What do you do with these?" And he's like, "Send them to the scrapper." You know, so I'm like, "What? Give me a break!" Oh, yeah.
Hey, there we go.
There we go. So he's
Yeah. Cool.
he's here working. Oh yeah, that's the one time that we changed the hubs. We put disc brakes on our bus that time. That's gonna be the
Nice.
next bus to get that running, because it's been a few years since I decommissioned that one, took the batteries out, and yeah, we're gonna be getting all these buses running. Eventually, maybe we'll hit a show where we take them all at the same time.
I definitely think Talak should come up and do a video with you. His video skills are really coming up.
Good. That's good, because my
Good at the
video
shooting.
skills are
He's
going
not so
down.
good at the editing and publishing. I'll give you a little hard time.
Kevin,
I can only do one thing at a time. I can only do one thing at a time. I'm either shooting or editing. Like if I'm shooting, I'm not editing. You know the drill. You know.
There you go.
awesome.
In fact, I'm
All right,
I'm
Got a
editing
video
right
on
now.
YouTube from
I'm
me. That's what
editing.
I'm giving him a hard time about. So, all right.
Nice.
Yeah, there you go. Yeah,
All
I
right,
kind of.
we're gonna. Oh, go ahead. Yeah. What was the last thing there?
That's it. No, that's it. I've said I kind of given
Okay.
up on my videos for right now. I'm just trying to. I had a bad year last year because I had too many like employees and too many things, but this year is like I've turned it around, you know. So I'm a little bit more involved with the sales and stuff. So I don't have time to do as many videos. But definitely the bills are starting, and so we're definitely gonna have to do some videos about that, because yeah, it's
Nice.
starting to get exciting.
We'll
And
play
what-
with your cool shit and make videos about it for you and promote you.
Yeah.
Yeah. Is your shop over in your rancho of Cucamonga also, or is that somewhere else?
Yeah, Rancho Cucamonga. Yeah. Mhm.
Okay. Well, I'm 10 minutes from EV West, so I could drive up.
Oh, there you go.
Yeah.
There you go.
Yep.
Yeah.
Road trip.
Good.
I'm up for it. Let me know.
All right.
Oh, and
Can
And
hold the boom
furthermore-
mic.
really great day for you Rivian owners today too, or Rivian shareholders.
Investors, yeah,
There you go.
not me.
50%.
Yeah, we talked about that in pregame, Tom.
Yeah.
Yeah,
Our company's
sorry.
not gonna die. Our Rivians are not gonna be unsupported.
That
Anytime
Gen 2 is nice. I drove it yesterday. It's
You did?
it's nice. Yeah.
Oh, wow.
I
Yeah.
want that roof thing that turns down, because that roof cooks my head all day, you know. Right now, if you look at my thing, it's like 130 degrees inside my my truck right now. So
You need panels up there, solar panels.
Yeah, there you go. Up
All right, we're
tempo.
gonna end the recording there. This is awesome. Jehu, thanks so much for doing this. We'll hang
Oh,
out
thanks
for a
for
little
having
bit. Recording, yeah, it's great. And August 5th through the 9th is my target. I'm gonna put up the class, and it's gonna be a collaboration. It's gonna be Jehu batteries, and we're gonna do amp revolt in Lancaster, Pennsylvania. We're gonna have an EVOS thing, and maybe we're just gonna pull all parts from everywhere and train people on everything, and we'll see how it goes. And if we could do it in a week, we could do it out there. We could do it anywhere.
There you go.
So, yeah. All right, cool. Thanks so much for everybody, and we'll hang out for a bit. But that was a good EV hangout.